how to do Hess's law. And most of you were okay with it. And I said, all right, well, let's make sure we can do this problem because it is like the one on the test. Does that sound familiar? Good. Would you like time to do this on your own? Okay. Hey Siri, set a timer for 3 minutes. Was anyone not here yesterday? Oh yeah, Will. Anyone else? Not here yesterday? Okay. So just a quick review in case you do not remember. Our goal is to take these three reactions and add them together in a way that everything cancels out except these pieces. So if I look at SiH4, it's on the left here. Is it on the left here? No, it's on the right. So I must reverse this reaction to get that in the correct place. Does it have the right coefficient? Yes, it does have the correct coefficient. All right, welcome back. All right, so that makes this a negative. Are we okay with why that is a negative? Okay. Then I'm going to look at silicon dioxide right here. Is it on the right? Yes, it's on the right. So I feel okay with that. It has no coefficient there. Well, it's a 1 and a 1. So that matches as well. So do I need to do anything with this value? No, it's good. All right, then I'm going to look here at the water. There's one water on the right, but there's two over here on the right. So what do I need to do to this second thing, or this third thing? Everything here has to be doubled. So I'm going to multiply that by 2. All right, when you do all that math, it's negative, right? 1429 kilojoules. How many were fine with that question? You should put kilojoules or you will lose 1 point. The unit is worth a point. All right, Sam, I did stuff with the oxygen. Okay. The oxygen, I'll talk it through. But once I figure out what to do on all three, even if there's an extra one, I can typically move on. But I did fix the oxygen, because when I multiplied this by 2, this became a 1, right? What is 1 plus 1? 2 oxygens. It's there, but I didn't overtly do it. I covertly did it. Are we all right with that? And all the other crap would have canceled out. The solid silicons would have canceled, because remember, this one's really over on that side. The H2s would have canceled as well, because this is here, and remember that one was over there also. So we're solid. Okay. Now, this question on the test has more parts to it. It looks just like, do I even have this one? No, I don't. Okay. But I will just tell you right now, for this question on the test, where is it? All right. It will ask you the following things. It will ask you for what we just did. It will ask you, and don't say them out loud, it will ask you, is the process endo or exothermic? You okay with that? All right. It asks you to write this equation out in words. Like something something plus oxygen goes to something something plus water. Yep. And you can say, oh, that's it. But I will tell you, this is one of the most missed parts of the test. If you look up what that is on the internet, it will tell you it's silane. Silane is its common name, but that is not its name for how we do this process. All right? I'm not going to tell you. You should know, or you can look up the rules on how to name covalent structures, because we did that. We did it here also. What else does this? Oh, it. This is word for word, number for number, the exact question from the test that you'll take tomorrow. Yeah, you definitely should. All right. Now, say that again. What do you mean, two gases? This is, oh, you mean nonmetals. Yeah. Yes, you should consider this as two nonmetals. It is a covalently bonded substance. That definitely will help if you're looking it up. Okay, now, friends, there's a question that will say, it's the, so one of them, the answer is the math that we just did, right? It will say, what would the enthalpy of the reverse reaction be? And don't, like, how would you know that? Say it with more confidence, Post. It's the opposite, meaning the same magnitude of number, but just a different sign. Yeah, like it will ask you to do the math, and then the next part, technically, I think it's in the next part in order, it says, what would be the enthalpy of the reverse reaction? And I'll tell you what, in my multiple years, it blows me away how many people just leave that question blank. They're like, IDK. There are rules for naming them. We learned them in chapter 2. Okay, so this is one style of your question. Hopefully you are okay with. Let's talk about the test. There are 12. I'm going to change this for sure. Yeah, right here. That's what MC stands for. This is from last year. I have 12 multiple choice, but as I looked at them today or yesterday, most of these are math. So this number is going to be smaller, and there'll be no math on the multiple choice because there's no reason to test you, even though chemistry is kind of a math class. I would estimate there'll be around 8 questions, and they'll all be content questions that you can get from the reading and or the note taking. But they might not be things we spent 20 minutes talking about. All right, then FR, what does that stand for? Free response. There's a calorimetry, a delta H, F naught, or heats of formation, and then a Hess's law. Hess's law is what we just did, and I won't spend any more time on it today. We'll go over both of them. Calorimetry, you ready? Calorimetry is when we put stuff in a cup, we measure how the temperature changes, and we use this equation, Q equals SM delta T, where technically there's a negative. Sometimes I write it, sometimes I don't, because I just remember, hey, if the temperature goes up, the answer must be negative. If it goes down, it must be positive. Does that sound familiar? Okay, so let's pretend I put 30 grams of AgNO3. Now, from memory this morning, just to save us some time, that's 169 grams per 1 mole. You okay with that? Okay, 30 grams of AgNO3 in 200 milliliters of water. The the temp goes from 20 to 31 degrees. Now, what I want to know the following. I want to know the Q for this reaction and the delta H in kilojoules per 1 mole. I'm going to give you 3 minutes to do that. So I just need to plug in the values. I have pretty much every value, right? So first, Q will be equal to 4.184, which is a number you have to have memorized or at least programmed into your calculator. All right? If you don't have it programmed in your calculator, before you come to class tomorrow, type 4.184 into your calculator. Then turn it on and write that number on your test. Okay? What's my mass here? 230 grams. What's my change in temperature? 11. All right, then I multiply. And I'm going to, this answer, give me in kilojoules so it's not such a big number. It should be negative. Good. How come, Olivia? Because it's exothermic. The temperature went up, so the system lost energy. Okay. Now, that's Q for if you have 30 grams, but here we want it if you had 169 grams, right? So I take this same number now, negative 10.59, and I want it per mole. So I have to find how many moles are in 30 grams of AgNO3. To do that, I just take 30 and divide it by 169. 30 169ths is equal to 0.17, is that what you said? Okay, good enough. 0.18, when you do that, you're going to end up like 60. 59.8. Are we okay with that? Sure. This one's harder than the test is, so those are different. It is right here. This one's good. You're solving for a different thing, but it's still okay. You want to try it? What we're solving here in this one is delta T. It's fine, right? We give you Q, we ask for delta T. Why don't you take a couple minutes to try that one? Hello, young man. Just leave it there. I'll have my TA do it. What's that? Yeah. Oh, I should pause this. Might be confusing you because you don't need a picket fence. This was probably me following up this with later. All right, so Q we now know is negative 44.4, right? Equals 4.184, and technically this should be a negative 2. Are you with me? So they're both going to cancel out so that your answer is a positive number. That's important. All right, what's the total mass involved here? 263.9, right? And then this is your X, correct? So you multiply these two answers. Does anyone have that number? Was that the 1.1? Okay, and that's kilojoules, right? So it was really 1104, but we've converted it, and that's important because this was in kilojoules too. The negatives cancel out, so I end up with what overall answer here? 40 point what? 36? Okay, we'll just go with 3 here. Now, is this your answer? No, that is equal to delta T, correct? So now we need to add 40.3 to this number, and we get 63.3 degrees. Did everyone understand that last step? Okay? When you do this math, you're solving for the change in temperature, which is not your answer. It's what it was previously plus your answer. Raise your hands if you're okay with that, though. Okay. Next up. Okay. Let's look at it here. All right. Now, I have cut the top part of this off so that I'm not giving you the entire test word for word. But Brindley, this is the exact question off the test. Word for word. I have no intention of changing anything about this question. All right. So at the top, it just gives you the reaction that's happening in words. And then it says give the balanced reaction. So it is somewhat difficult because you have to go from words to a formula. Now, it's sort of almost multiple choice because I have the formulas up here. But, just warning you, some of these formulas are wrong. Because I don't want to give you the answer. I have to give you some distractors or you'll be like, Davidson's so stupid. He made me write the formulas, but then he gave them straight to me in the table. Which, whatever. I've been giving you extra points for years. All right. So, once you have this balanced out, then you would do this problem. We're going to work through this problem with me making up something that's different than the actual. So here we go. Let's pretend the problem said you're making aluminum oxide from aluminum and oxygen. Now, that is not the problem, but I would work through this with me. So you would write aluminum plus oxygen goes to aluminum oxide. You okay with that so far? If you pay attention to everything I do and you can see up here, you can sort of do this entire problem. You could put it together. All right. The first thing to do then, I've written it out, but then I got to balance it, right? I'm going to put a 3 here, a 2 here, and a 4 there. Okay. So that's the first part. Now on the test, it's different. It involves iron, aluminum, and oxygen. On the very first day, I showed you this question before, and I told you the name of this question or this reaction. If you remember, you can look that up, and that would tell you also. All right. Then in B, using the table provided, and this is gigantic font and in bold for a reason, because what's this table in? Kilojoules. Now, I am not trying to be mean and ruin your life. I'm having you do it in joules because you need it in joules to do this problem down here. Have you picked up through the test you've taken that you usually use an answer later that you found earlier? That was a really weird to ask that question. Wait, but whatever. Okay, so this is going to be in joules, so I'm going to do this. Part B follows the equation. The sum of the products minus the sum of the reactants is equal to your enthalpy. Does that seem familiar? We did it 2 days ago, and you didn't mind it. Most of you were like, this isn't bad. So, the only product I have is here, correct? So I take the coefficient, 2, and I multiply it by the enthalpy that I find in this table. Al2O3 is the one that's kind of crossed out. It's right here. You okay with that? Negative 1869.8. Okay. Now, that's the only product. So I take the sum of the product, and then I subtract the sum of the reactants. Now, this part here is going to seem pointless, but I'm doing it to show you the process that you'll have to do tomorrow. So we take the coefficient of this, which is 4, and we multiply it by the value of aluminum in the table. Now, is it in the table? No. We never find pure elements in this table because they are always what? They're always 0. Now, tomorrow, that's not going to be a 0 probably. Okay, it's one of these. Now, tomorrow, you will use iron and aluminum, so there are zeros somewhere. But anyway, the process. Take the coefficient, multiply it by the number. Say that again, Caitlin. Because the delta H of formation of a pure element is 0. Because that's how it's found. I don't have to put energy to find oxygen. It's already here. Okay, plus, now I know this is stupid math-wise, but I take a 3, and I multiply it by the number I would find in the table, which is just a 0. All right? But tomorrow, remember, these will be numbers probably. All right, and then I do the math. This is simple, because this whole half equals 0, right? So you just take 2, and you multiply it by negative 1869.8. Will someone do that for me? All right. Okay, now you have to be careful. Is this the answer? No, these are in kilojoules, right? So it's really 2 more zeros. That's a big freaking number, right? It is a big number tomorrow. Don't panic. It is supposed to be a big number. This is a very exothermic reaction that I'm describing. All right, we'll get there in a second. All right, so that is your answer here, correct? Okay. Then, part C, which element is reduced in this reaction? Okay, now this is not is the one that gains the electron. On the last test, I would say the majority of people switched these up. Just please remember Leo the Lion says GER. GER, gain electrons reduced. So, tomorrow, there'll be a lone element on both sides. So the oxidation and reduction is pretty simple. Okay, now, letter D. I don't want anyone to say anything, but I want you guys to read that to yourselves and see if you can answer that question. And then we will work on letter E. Okay. We'll go to letter E. Notice it's in joules again. How many joules of heat would be released or absorbed if 15 grams of Al completely reacted with iron 3 oxide? Now, we're not doing that. We're pretending that we are here. Are you okay with that? So we're going to take and make a picket fence, because that's what I do half the time. What do I start with? Good, the 15 grams of Al. Good luck. We'll see you tomorrow. All right, 15 grams of Al. What do I need on the bottom then? Grams of Al, which I find on the periodic table are 27 grams per 1 mole. What must I need down here? 1 mole. And what am I trying to answer? Joules. So what do I need here? Joules. This huge answer right here, right? Negative 3739600. And then I find a number here. We're basically dividing this number in half. So I'm just going to say it's this number. It is negative 1880. Oh, did I get them all? 1, 2, 3. Nope. One more O. Is that right? Yeah. Let's just say it's that number. Who cares? It doesn't matter what the number is. Okay. It's what? Okay, thank you. Yeah, well, let's not worry about it. Who cares? All right, here we go. Now, letter F. Letter F is exactly this problem we just barely did on the previous slide. This is your joules, and you're solving for delta T. There's your initial. Okay, I'm not going to work through that because I just barely did it. What's that? Okay. It's right there. It's 5,000 milliliters, which would be 5,000 grams. Yep. No, technically C goes to E and E goes to F. That is also Q. But yeah, this is the Q with just the 15 grams. It's this. It's this answer. Okay. Maybe I'm not. Maybe that is it. I think I went out of order though. Here we go. This is the last piece on the test. The one we just did is typically the hardest. The Hess's is the easiest, and this is the middlest. So, this is, what's that? We've done multiple problems on calorimetry already today. All right, you have to draw a coffee cup calorimeter. All right, that's that. Then you just have to, I better talk about this because this makes kids mad. Give a balanced dissolution reaction. What's a dissolution reaction? It's not the net ionic. What's dissolution mean? It means it dissolves. So here's the thing dissolving. So K, NO3 goes to K plus NO3 minus. So it's like the reverse of a net ionic equation. It's how it's breaking apart. Okay, don't say it out loud, but just think through this. Besides that the problem tells you that it dissolves, how would you know potassium nitrate dissolves? Okay, don't say it out loud. Remember that part? Okay. Okay, thank you. All right, letter C, we've done a lot of times. Q equals SM delta T. You're just solving for Q. All right, this says joules. I won't mark it wrong on this one if you put kilojoules. I'm fine either way. Then in D, remember you take this answer in kilojoules, and then you just divide it by the given grams, whatever, over the molar mass. We did one of these already this very day, right? Okay, that will tell you that. What will tell you if it's endo or exo? All right, the positive or negative, or looking right here. That will tell you also. All right? Then, if silver acetate was added, would there be a precipitate? Don't say the answer out loud. If so, complete the net ionic. G, draw the apparatus you would use to do this experiment. What do you think? Doable? Okay. I really feel if you're with us, if you've read, you've done the sample problems, and you do a little bit of studying tonight, that this is realistically a test that you can get 100% on. At least the free response. Especially since if you watch the class video, you can pause it at certain parts and see the entire free response section of the test. Yeah, I'll bet you, no I won't, because then I'll have to owe all of you $10 because you'll just go do it to get $10. But if I were a betting man, I would bet under 5 people will watch this video tonight. If it's like most tests, it will be under 1. Okay, question.